This is the identification of the manufacturing processes used to make key parts in a Dremel rotary tool. The motor brushes are composed of a combination of powdered materials, most likely graphite and carbon powders, as well as a binder. This mixture is pressed into form using a hydraulic punch and die. The initial fragile state is called the green stage. They are then baked or sintered. This usually warps the brush, so they must be ground into their final shape. The copper spring is pressed on after. The Torx head screws were most likely made by thread rolling. The screws start as a long coil of wire that is fed through a machine that cuts the wire to the desired fastener length and then shapes the head using a die. Then the threads are formed using a thread roller that extrudes the thread shape rather than cutting it. While screws can be machined, the process is very expensive, slow, and wasteful when compared with thread rolling. Threads that are roll formed are also stronger than cut threads because of the residual stresses left by the rolling. The brush cover plates, nose piece, main housing, and switch are all made using injection molding. Injection molding is a high-rate production process with good dimensional accuracy. It is a very versatile process and capable of producing complex shapes. The most obvious signs of injection molding are ejector pin marks, which are present on all but the nose piece. The nose piece has internal threads, meaning the part needed to be unscrewed from the mold. Alternatively, the nose piece could have been cast and the threads formed in a separate operation. The rubberized coating on the main housing would have been overmolded, firmly integrating the rubber coating into the housing. The switch is made of 3 different injection molded parts that are held together with 4 copper clips. The collet retainer, and rotor end all appear to have been CNC machined. Each part has visible turning marks and precise geometries. The small outer diameters and short lengths mean these parts could be mass-produced quickly on a dual-spindle Swiss lathe with a bar feeder. The collet could have been made from an extruded aluminum tube and expanded using a mandrel, and have the slots cut in a later operation. There aren't any visible seams, making it unlikely to have been cast or metal injection molded. The knurling and internal threads on the retainer would have been very difficult to create using casting. The rotor end has fine threads, grooves, and a precise internal bore, which are all features that would be best made on a CNC lathe. The motor, stator, and rotor have drawn copper wire windings. The copper is pulled through successively smaller and smaller dies until the desired thickness is obtained. The plates were either stamped, laser, or water jet cut from silicon steel. The plates are TIG welded together. TIG welding is used because of its ability to produce a small, controllable arc and the cleanliness of its weld. There is evidence of machining on the rotor plates, done to balance the assembly to reduce vibration during high RPM use. This small rubber insulator could have been made using either compression or transfer molding. Compression molding uses a pre-shaped charged material and places it into a heated mold. The material is then pressed into shape using a plug or die, similar to die forging metals. Transfer molding preheats the material and injects it into heated molds and is better for more complex parts. Compression molding takes longer to cure, but the molds are cheaper than those for transfer molding.